Hello and welcome. In this tutorial, you will learn about deep learning-based instance segmentation with MVTec HALCON. As a result of instance segmentation, you get both a bounding box and a pixel-precise mask of the trained instances in an image. Thus, it can be especially useful if you want to further post-process your results, say for defect evaluation or bin picking, for example. In HALCON, instance segmentation is implemented as deep learning-based object detection, followed by a segmentation inside the bounding boxes. If you haven't seen our tutorials on object detection, we highly recommend watching them first. Note that the bounding boxes can be axis-aligned or arbitrarily oriented, just like for object detection. In this video, we will primarily highlight the differences between object detection and instance segmentation. Let's begin by going through the HDevelop example, DL Instance Segmentation Workflow.hdev. In this example, a model is trained to locate and segment these pills. To train the model, we must provide a labeled dataset. To label the data, we recommend using the MVTec Deep Learning tool, which you can download for free from our website. Just like training for object detection, the samples include the coordinates of the bounding boxes and corresponding label IDs. The only additional requirement for instance segmentation are the masks. In the example, we use the procedure determine DL model detection param to estimate advanced model parameters based on the given dataset. Then we set the model parameter instance segmentation to true. This is what determines whether we create an instance segmentation model or an object detection model. Next, we create the model with create DL model detection. Those steps are identical to the object detection workflow. Now we can run the deep learning training. As with object detection, we use the mean average precision to evaluate the quality of the trained model. Note that the intersection over union, which tells us if a localization is correct, is calculated based on the masks by default. In contrast, the inference parameters max overlap and max overlap class agnostic are still based on the intersection over union of the bounding boxes, just like for object detection. Next, we evaluate the trained model as usual. Much more information regarding the precision, recall, and the confusion matrix can be found in the respective object detection video tutorial. Lastly, the inference is also similar to object detection. The DL result dictionary now additionally includes the masks as region array, similar to the labeled data we used for the training.